Number 6, integral from 0 to 1 dx of e to the x minus 1. This is an improper integral because as x approaches 0, we're going to be divided by 0 on the bottom. Okay, this one is actually quite simple to evaluate. So let's just do it. Let's rewrite it as a limit first. So limit as t approaches 0 from the right, integral from t to 1 dx of e to x minus 1. What's the technique to evaluate this integral? Well, we can multiply both the top and bottom by e to the negative x. Why do we want to do that? Well, the top becomes e to the minus x dx. The bottom becomes 1 minus e to the negative x. So here, we can make a substitution. U is 1 minus e to the negative x. Du is e to the negative x dx. Okay? And now, after we make the substitution, we had to change the limits of integration, by the way, so that's what I did. You got to be careful. It looks messy, but this is how we do it. Okay? And then integrate, that's just natural log, and then fundamental theorem of calculus. So as t approaches 0, this is just a finite number, so it's going to be finite. But this one, as t approaches 0, we have 1 minus e to the 0. E to 0 is 1, so 1 minus 1 is 0. ln is going to approach 0. So this is infinite. So therefore, the integral diverges. Okay? This, by the way, is a good example of maybe we should have just evaluated the indefinite integral first to avoid this seemingly messy limits of integration because of the substitution. Okay? Sometimes if you've seen in my other problems, I evaluate the indefinite integral first and then I take the limits. Sometimes it's just cleaner to do it like that, but you can always do it like this where you make the substitution with the limit notation and all that already. It's just a little messier, but still doable, okay? Here, could we have done a comparison test, by the way? You might have been able to, but you got to be careful to pick a proper one because since this one diverges, we found it by actually calculating it, you got to pick a function who is smaller than 1 over e to x minus 1. If something smaller diverges and your thing's even bigger, then your thing diverges as well. That's the proper way to do the comparison test. If you've been following on this series, I've been trying to hammer at this point home that you have to do comparisons properly. Okay, so you would have to pick a function, at least in this interval from 0 to 1, in which that function is smaller than 1 over e to x minus 1, but also diverges. So then we can conclude that our function diverges as well. So I'll leave that up to you to try. Okay, but you can see we can actually just calculate this integral. Not too bad at all.